Dymedix is an innovator. The sensing technology for sleep had not substantially changed in more than 30 years. After having his own sleep study, our founder saw a way to improve on all of the existing technology with the highly sensitive technology known as polyvinylidene fluoride film, or PVDF. PVDF is a highly chemical-resistant film that possesses both pyroelectric and piezoelectric properties. These characteristics were discovered by the Curie brothers more than 100 years ago and further defined in the late 1960s. It has been utilized in literally thousands of applications in medicine, industry, and defense. Rate-responsive pacemakers, high-end electronic stethoscopes, ultrasound, and even advanced Navy sonar, to name just a few. PVDF is a poled polymer, meaning it has a positive charge on one side and a negative charge on the other. It reacts to the changes in pressure, temperature, and movement through the movement of electrons from one side to the other, the basic definition of electrical current. This change in current can be measured by the electronics developed by Dymedix. The biggest advantage of using PVDF as an airflow sensor is in its response time. Traditional sensors like thermistors and thermocouples measure airflow by changes in temperature, but the response times can be as much as 1 to 3 seconds. Consequently, the data must be averaged to produce a waveform on a polysomnograph. One study said that therms miss anywhere from 21 to 25% of all events. PVDF has a virtually instantaneous response time of 5/1000ths of a second. It does not have to average the data and is therefore a better event detector than traditional thermal sensors. It will not miss events. The American Academy of Sleep Medicine, the AASM, recommends the use of therms for the detection of apneas and air pressure transducers, or APT, for the detection of hypopnea. APT is the other traditional technology used for airflow in a sleep study and utilizes a cannula. More sensitive than therms, the air pressure transducer does not detect apnea as well because it is not linear to airflow, and per the recommendations, both therms and APT are needed. PVDF is linear to airflow and will detect both apnea and hypopnea equally well without the need for two sensors. Unlike APT, it does not utilize cannula, which can become dislodged or clogged with bodily fluids. As we will show later in this presentation, placement of the Dymedix PVDF-based airflow sensor is very much like a peel-and-stick Band-Aid. No prongs to go up the nose, so there is greater patient comfort. Another bodily function measured in a sleep study is respiratory effort. While it can be measured with intercostal electrodes, it is most often measured with a band around the chest and one around the abdomen called respiratory effort belts. Respiratory inductance plethysmography, or RIP, consists of a band with a wire embedded in it that goes completely around the body. In its calibrated form, it is capable of showing that and a number of other detailed data. Unfortunately, as a patient moves around during a sleep study, it must be recalibrated. This necessitates the waking of the patient, and it is not practical for an everyday sleep study. Most labs use these belts uncalibrated. The other problem with RIP belts occurs as the wire inside is stretched over and over with each breath. Wire fatigue is reported by many labs, producing a noisy signal after a short period of repeated use. Piezo crystal and piezo ceramic belts are no longer acceptable because they can show a false positive for paradoxical breathing. A recently completed 50-patient study found the perfect fit belts to be equivalent to RIP as it is commonly used. With low-profile, quick-release buckles for greater patient comfort, the perfect fit belts were designed to stay in place and be easy to adjust. PVDF shows true paradoxical breathing, and even when flipped completely over, they will not change polarity. When used in conjunction with the Dymedix airflow sensors, the signals will sync up perfectly. This is the great benefit of identical response times. PVDF can also be used to detect snoring. Because of its high sensitivity, the Dymedix snore sensor does not need to be on the sweet spot, thus avoiding carotid artifact. Setup is simple, and special noise reduction circuitry provides the cleanest baseline in the industry, allowing for the detection of subtle snore events. Dymedix also was the first to manufacture unique electrodes for the legs and the chin, along with snap electrode lead wires with high strength and durability. Better data starts with better sensors, and better sensors start with Dymedix.